In today's video, we'll be talking about product rule. And one thing about product you need to know is y equal to u v. Okay, it means that you multiplying two things together. For example, let's say we have y equal to 2x into bracket of x plus 1. That is, you can see this. It means that 2x was multiplied with x plus 1. Okay, so whenever they multiply two things, just know they are talking about using product rule. So now let's say we have the formula for product rule is dy over dx equal to u dv over dx plus v du over dx. That is, which can be simply mean to be dy over dx equal to u dv plus v du. Okay, that is the formula for product rule. So now let's assume that we were given something like this. Okay, let's say we're given y equal to 3x raised to the power of 6 minus 10 into brackets, then into the bracket of x raised to the power of 4 plus 30. As you can see this, they were both multiplied together. Okay, that is, we can say this should be our u and this should be our v. Okay, that is, we have our u to be equal to 3x raised to the power of 6 minus 10. And then we have our v to be x raised to the power of 4 plus 30. That is, we'll have to look for du, and we'll also have to look for what? Dv. That is, the du means we differentiating du, which is 3 multiplied by the 6 will have to come down, then x raised to the power of 6 minus 1. Then minus, we differentiating 10, which is a constant, is also what? Is also 0, okay? Then we'll have to come and differentiate our dv. That is, our dv here is 4x raised to the power of 4 minus 1. Then differentiating 30, which is also a constant, will give us 0. So we have 18x raised to the power of 5, and then we have 4x raised to the power of 4. So now you can see we have we have our u, our du, our v, and our dv. So the formula is dy over dx equals to u dv plus v du. That is, our u is 3x raised to the power of 6. Okay, we have it as 3x raised to the power of 6 minus 10, and we have a dv to be 4x raised to the power of 3. What I mean is, we are multiplying this u that you're seeing here, and this dv you are as well seeing here. Okay, so now plus, we have, what's it called? We have our v to be x raised to the power of 4 plus 30 into the bracket, and then we have our du to be 18x raised to the power of 5. So as you can see here, we can as well use 4x raised to the power of 3 to open the bracket. Alright, that is, we're using it to multiply the 3x raised to the power of 6. So we have 12x raised to the power of 9, right? Minus, we're using 4x raised to the power of 3 to multiply minus 10, which is minus 40x raised to the power of 3. Now coming to the other side, we have 18x raised to the power of 5. So using it, we'll have 18x raised to the power of 9 plus, then we'll multiply 18x raised to the power of 5 with 30, which will give us 540x raised to the power of 5. Alright, now looking at this, we can as well rearrange. That is, we have 12x raised to the power of 9 plus 18x raised to the power of 9 minus, no, we have plus 540 raised to the power of 5 and minus 40x raised to the power of 3. Okay, now looking at this 12 and the 18, they have the same power, so we can add them to give us 30x raised to the power of 9 plus 540 raised to the power of 5 minus 40x raised to the power of 3. So that is the solution to this question. I hope you understand that. Okay, now let's say we have something else. They give us y equal to x sine 2x. So you can as well pause this video and see if you can try this out yourself. Okay, now let's say the x is, this x you're seeing is our u. Okay, all right, so we'll say our u is equal to the x, and our v is equal to sine 2x. Now we need to find the u, that is differentiating u in respect to x, which is 1, We need to find out dv, which is 2. We have it as 2 cos 2x. Okay, now let me explain. Sin x is automatically going to be cos x. Okay, and let's assume we have sine 2x. This will be 2 cos 2x. Okay, now let's also assume we have sine 4x squared. What does this mean? We are differentiating the 4x squared, which will give us what? 8x cos that same thing. You can say the sine 2x we did. We differentiated 2x to give us 2. I hope you understand that now. Okay, now, so the formula here is dy. We have a formula to be dy over dx being equal to u dv plus v du. Okay, so now our u, automatically we know what our u is, which is the x, and then the v is 2 cos 2x. Thank you. Okay, plus we have our v to be sine x, sine 2x, sorry. Then we have a du to be 1. Okay, now multiplying this thing will give us 2x cos 2x plus sine 2x. Okay, so that's the final answer to this particular problem. I hope you understand that. Okay, now let's see. Let's assume as well that we're given y equal to x cos x. Okay, now let's assume we're given something like this. You can also pause this video to try it out yourself if you can actually, attempt this. All right, now, normally what we'll do is these two are being multiplied together. So you're using product rule. So the u is equal to x and our v is cos x. So we'll do for the du which is equal to 1, and then we'll differentiate v in respect to x, which is the v to be equal to negative sine x. We have it to be negative sine x. Okay, now of course we have some special rules you need to know, which is sine x is equal to cos x. All right, we have cos x to be equal to negative sine x, and we have tan x to be equal to sec square x. Okay, there are some basic rules you just need to know, and if you know them, you'll be very much good to go. Okay, now we have our formula to be dy over dx equal to u dv plus v du. That is, our u here is our x there. Okay, and dv is minus sine x, plus we have our v to be cos x, and we have our du, which is 1. Okay, so now multiplying them, we have negative x sine x and plus cos x. We can also rearrange this to be cos x minus sine x sine x. I hope you understand this. So this is the final answer to this particular problem. Thank you for watching. See you in my next video. Before then, do well to subscribe and like this video.